Okay. So last Tuesday, we went over section 1 and 2 of chapter 8, learning how to test about the mean. In the test of the mean, we have two situations. The first one is when sigma is known, we use the z distribution. And when sigma is unknown, we use the t distribution. Essentially, we want to know the test value and the p-value. We are going to continue with the test for proportion. Like in the test for the mean, we are essentially interested in learning about how to find the test value and the p-value. So in chapter 6, we learn about the sampling distribution for sample proportion. The sampling distribution for sample proportion has mean, the population proportion, and standard deviation, the square root of PQ over N. So this is going to be used to compute the test value. So like in the test for the mean, the test for proportion are of three types: left tail, right tail, and two tails. Left tail is when the critical region is to the left. The alternative hypothesis is proportion is greater than something. I'm sorry, less than something. And for the right tail, proportion is greater than. And for the two tail, proportion is different from. So we have those three cases. So the test value here is p hat minus p. P is the value that you have at H0, the hypothesized proportion. H0 tells us what the value of the parameter is all the time. So that is what we use. That's why we like to write it as equal to, because it's the value of the proportion. So as we did for the mean, we can use a calculator to get the test value and the p-value. I want us to recall the steps in hypothesis testing. First, you want to identify the claim. This claim is usually an expression in a question of the problem. Identify the claim. Using the claim, state the hypothesis. And 3, put the test value. The test value is what is used. It is generally p hat minus p divided by square root of pq over n. And 4, you can either use the critical value or the p-value to determine if the test value is in the critical region or not. P-value is equal to the probability that z is less than. Here we will have a capital Z and a small z, which is like the test value. For a left tail, it is equal to p that z is greater than zt. For right tail, this is to express the tail, and it's equal to p that z minus z two times z is less than minus zt. For 2, we did this last time for the mean. I'm just trying to recall it. An important part of what I want you to realize is at the level of conclusion. Today we are going to pay attention on how to write conclusion. Now, conclusion. If the claim is H1, which happen most of the time, not all the time. If the claim is H1, based on your decision, you will say at alpha equals to maybe A, there is or there is not. You can say there is or there is not enough or is significant. There is enough evidence or there is not enough evidence to support the claim. Based on the decision, your conclusion will be at alpha equals to A, there is enough evidence or there is not enough evidence to support the claim. Here the claim is H1. If the claim is H0, if the claim is H0, your conclusion will be alpha equals to A, there is enough evidence to reject the claim. And you list what that claim is about. As we move on, you are going to observe that sometimes I use the word reject, sometimes I use the word support. I use support when the claim is H1, reject when the claim is H0, depending on the decision that you will take. The decision is always about H0. There is no H1. We test H0. And knowing the information we get from the test about H0, we make a conclusion. So if the claim is H1, our conclusion will be either to reject or not to reject. I'm sorry, if it is H1, it's either to support or not to support. What is the idea here? We say that H0 is the status quo, it's what everybody generally take it. We are used to drinking warm drinks when it is cold. Somebody might now make a claim that it is bad to drink warm drink when it is cold. That is something unusual. We can support or we may not support. Okay, we are used to drinking cold water when it is, hot water when it is cold. That is what we are used to. Somebody now claim it is not bad to drink hot water when it is cold. It's not about supporting, it's about rejecting or not rejecting. So if it is what we know, we may say we are rejecting that claim or we are not rejecting it. But if it is something new, we are supporting or we are not supporting. That's just a technical way of putting it. So let's look at some examples for testing proportion. Can somebody help us read the example? Anybody feel like reading? Or is it too cold to read? Yeah. Okay, what is the claim here? What is the claim? I told you, you find the claim on the question. Can you see the claim? The new method is better than the old one, right? New method is better than the old one. What was the proportion of success in the old one? What is the proportion of success in the old method? 30%. So we are going to use that. A lot of students are on Zoom, so bear with me that I will be struggling to write on the screen. So we are going to say that claim. I think you saw that just expressed in the question. That is very important for us to know that claim in order to set our test. Is better than old. So we are saying that P is greater than 0.3. proportion is greater than 0.3, the proportion of success of surgery. Do we get that? So now we state the hypothesis. This claim H0 or H1. H1 greater than, P is greater than 0.3. H0 will be P is equals to 0.3. And we want to write here claim. You don't have to, but so that you don't forget what that's right. Then the next thing is the test value Z, which is P hat minus P over square root of PQ divided by N. Now we will go back to the problem to know the information, to learn about the information that will help us to get what P hat is. But if you're using calculator, you don't need, you just need to know it, right? So we get back there, we are going to come back to state the test value, the P value, decision, and conclusion. So what is N here? 225. N equals to 225. And what is X? Number of success. For this sample of 225, using the new method, what is the number of success? Do we get this? Do we get this? So we also want to know N minus X. We require both numbers to be at least 5 to proceed with the test, which you will always get anyway. But you should know that we can proceed with the Z test because both numbers are greater than 5. So P hat will be 88 over 225. What is 88 over 225? 0.39. So we will use this to find the test value. 0.39 minus 0.3 divided by 0.3 times 0.7 over 225. You don't have to do all this because you are going to use calculator. I just want to show you what you are supposed to do if you don't have a calculator. I require that you all have calculator, so we have to be using calculator. Otherwise, we won't be able to cover everything. So let's go to the calculator. You will go the same way, start, test, one proportion, Z test. If you have questions about the use of your calculator, let me know. H0, what you have on H0? What is on H0? I have only one screen. So P0 is what? What do you have as P0? 0.30. is what you have on H0, that is P0. Then you will enter, you have N, you have X. N is 225, X is 88. But sometimes I can ask you, what is the sample proportion? Remember, it is X over N. If I ask you that in a test, I want to check that you know what you are doing. What is the test value here? Has anyone completed? Choose H1, P is greater than. What is the test value? 2.98. And what is the P value? 0.0014. Because this is a z-test and we can easily use critical value for z-test, I will show you the critical value method at the same time. This is a right tail test. What was alpha? Anybody remember what alpha was? 0.01. Alpha was 0.01. So for 0.01, the z value is 2.33. 2.33. So we want to make the decision. We can make this decision in two ways. Either we use the p-value, that's the area to the right of the test value because it's the right tail test, or we use the critical value, which is 2.33, to decide, is this test value in the rejection region? Is the test value in the rejection region? When you are using the p-value, you compare it to alpha. If it is less than alpha, it's shrinking to the rejection region. If it is bigger than alpha, it gets out of the rejection region. Or you compare it to the z, test the critical value. This critical value, you just want to find the area so that the right of z is 0.01. So you will find 2.33. If somebody asks you about it some days. What is the critical value? Is the value so that the right or left area, depending on whether it's left or right tail test, is level of significance. So is this test value in the rejection region or critical region? Is it above or below 2.33? Above. When it is above, do you feel like it is in the rejection region? Yes. So decision. For your decision, I want you to take only one method, p-value. I'm not going to test you on critical value. I will be explaining. There will be no time for us to be doing both. As you can see, it means essentially the same thing. How do you determine the position of the test value? You determine it by estimating the area tail from it, or its position with respect to the critical value. But most commonly, p-value is used in research. That critical value is only used at a really lower level to explain in class why it is rejection. So let's say p is less than alpha. So reject it's 0. .33 is the z value, so that the area to the right of z alpha is 0.01. We have done it before in chapter 6. I used to give you that question. So yes, 2.98 is the test value, that is the reflection of the sample. 2.33 is that critical point from which we believe we have gone too far, not to be in line with the H0, the null hypothesis. So there are two values. Usually I don't like speaking about the critical value for them not to be mixed up like this, but you can understand it. Remember when I explained the hypothesis testing, I said we can say it is no more consistent with the null hypothesis. When do we start feeling like it's no more consistent? From the critical value. That's why the word critical value. Some people call critical region. So that value is here. Where does it come from? Level of significance alpha. The level of significance. We want this tail to be alpha. I don't ask you that question, but I just want you to know. As I told you before, we have two ways of analyzing this. I'm sorry. We have two ways of analyzing this. Either we think about the critical value and then position with 2.98, we will position it somewhere here. And we will say that it is in the rejection region because it is after the critical value. Do we get this? This is after the critical value. But suppose you don't know how to find this critical value, as I just said now. You don't know how to find it. But you know the p-value, which is the area to the right of the test value. And you see that area to be less than alpha, meaning that it is in the critical region because the right tail is smaller than the tail after the critical value. It gets into the critical region. General rule is this. If P is less than alpha, reject itself. Otherwise, do not reject itself. Do we get this one? If P is less than alpha, reject itself. Otherwise, do not reject itself. So here P is less than 80, so we reject itself. Do we all get it at this point? If you don't know how to find this critical value, don't worry about it because you don't really need it. It's like I'm showing you two methods to make a decision. Either you use critical value or you use p-value. I like that you use p-value because the calculator doesn't give you critical value, does it? Do you see anything like that on your calculator? You have p-value. So that's why I want us to use p-value. So what should be our conclusion? What should be our conclusion? Remember, we have two ways to conclude. Either support or reject. Which of the two should we use now, based on what we said at the beginning? Is it about supporting or about rejecting? We use support when it is H1. The word support comes more often because claim should be something that is unusual. But somebody might feel like making a statement about the parameter that is common. For example, we might say, I forgot my mask. You should tell me. But there is social distance, right? I should go get it. I wanted to say, you don't want mask, right? When you have to beg as a parent, that begging mask is good. Okay? So when you remember. I remember doing this in my senior year when I started So you might want to check if wearing masks is helping in resolving the contamination, right? Is because when you wear it, I always feel like removing it because I'm feeling something unusual is on me. So that is when it is unusual, that is what we really call claim. But sometimes what is normal can be claimed because people are so comfortable and a new idea is coming. Maybe we want to change from face-to-face to online. Somebody say face-to-face is much better than online. That is a claim at a moment where something is have to make people to change. So the claim sometimes can be what is usual. And in that case, the decision will, the conclusion will be about rejecting it. No, you are wrong. But when the claim is unusual, we support or we do not support. Is this claim H0 or H1? Do you see why I put the claim? Oh, so no. So no, that's what we want to do, you know, that's what we want to do. We want to discuss and understand what we are talking about. So the test is like you are putting information into a computer, and at the end it will give you a result that you will use to make a conclusion. So we start. We always test the null hypothesis regardless of whether it is the claim or not. At this point, we are not calling it the claim or not. Always about H0. So the test value is about H0. The p we put here is 0.3. The hypothesized proportion. Hmm? P is the value you put on H0. That is why we like putting it equal. It could be mu. It could be p. The parameter equals that value is what we. So we are saying, assuming that we want to compare what we have, what we always have, with the new one. So P is the new one. P had E, I'm sorry, P is the regular one. This is the regular one. P had is the new one. We are trying to compare both. And we want to see how far away the new one is to the old one. If it goes too far, and this is from a sample that we have taken, we may question the old one. Because what we have now is not like what you have always said. So we are saying that the method we are using now for eye surgery is 30% successful. Now somebody proposed a new one and want to claim that is better than the old one. We are going to try it on 225 people, just like people might want to try the COVID vaccine. So we will get a sample and try it and see the proportion of success. Our way to compare it is to take the difference. We are using this because it's the units of the random variable, the standard deviation, to find the z value so that we can compare it to this z value. Actually, that is the objective. So if we feel like this is not too far, we will say there is no difference. We do not reject itself because the sample we have is consistent with it. We do not reject. If it is not consistent, we reject. So we have done this. We come back now to the claim. And look, was the claim H0? If the claim was H0, and we have decided to reject it, then we will say there is enough reason to reject the claim. Yeah. No, you know, say what you have in your brain, then we will clean it. If it is not the right one, we take it. Is that right? When we say what is not right, we clean it. If you don't say it, you remain there. You know, some people, their room is always closed. Like my children, they're always closing their room. But if you get there, you might feel like getting a lot of stuff out. There is no sigma here. This, this, this is a new test about proportion. So this is what we are saying. You will, and that's why we are, when we are few, that's why it's easier. You are free to come to class, okay? But I want to tell you, when there are few students, let's take advantage of it. So what I'm trying to say is this. We knew that the proportion of success was 30%. Management want to change the procedure. Should we change or not? We don't want to change if it has the same result, because you have to buy new material and invest a lot of money. So you say, somebody said, no, the new procedure is better. If it is better, let us try it on 225 people and see the proportion. We come up with a proportion of 29. We might want to feel like it is different and it is actually better. But statistically, we do not just say because the sample is better, it is better. We want to check the significance of how better it is by taking this test value, which is a z-value, and compare it to a critical value from which we will believe that after it, the difference is true. It is not just by chance. So this critical value is what helps us to position ourselves from where we know the difference is significant. If it was somewhere here, if the new one was somewhere here, we say, okay, just go away with it, we don't care. If it was at 0.25, say, no, we don't need it, no problem, right? It will be consistent with the old one to some point. If it is 0.3 to 0.33, we might still say, yeah, it's different, but it is just by chance. So from where do we begin to feel like this difference is really the difference? We set a limit. That limit comes from the level of significance that tell us this. The next thing is, how do we determine that our z-value is bigger than this or less than this? We can determine it in two ways. Either by checking the area to the right of that test value. If it is smaller than alpha, we know the number will be bigger because it will go on the right side. So coming back to this point, our decision will always be about H0. So how do you behave with respect to the original one? Once we have taken this decision, our conclusion now is what we want to tell the population. We want to tell people our conclusion. At the hospital, they will tell you your test is negative. What does it mean? Normally, negative is bad. It means we were not able to detect that you are sick. And you go home, sometimes even happy. You know that? People are happy when they tell them that the test is negative at the hospital. Is that right? Right. To reject H0. It's a negative thing, but people are happy. It means
they are healthy. But if they say the test is positive, that means they have detected elements that you are not well. So this one will always be there, either positive or negative. Then the conclusion will come later. Conclusion will be support if claim is H1, reject if claim is H0. Most of the problems, it will be about support. But just pay attention because some problems is about reject. So here should be support or reject. Support. Now, are we going to support or not support the claim? We are going to support the claim because we have rejected H0. If we did not reject H0, we will say there is not enough evidence to support the claim. If we reject H0, there is enough evidence to support the claim. If we do not reject H0, there is not enough evidence to support the claim. Do we get this? I was supposed to explain this at the beginning, but you will not understand if we are not working it practically. I will just say grammar and write and write and write and write, and it will be a lot of writing. So I knew we are going to be slow as we move on, especially if you want to understand. Okay, so the conclusions here is at alpha equals to 0.01, there is enough evidence to support the claim that the new method is better than the old one. Actually, the sample was indicating that, but we were not sure if it is a significant difference. That's why we do the test. Okay? Sometimes I don't know whether it's my glass that I don't have or it is the mask. Okay. We are now going to conduct tests for, we have 30 minutes, and what we are going to use calculator. You have already understood this. I'm just going to tell you, this is how you do the test for the difference. This is how you use calculator, okay? If you want to read more, you go back to the PowerPoint. And so in 8.4, we are going to be testing difference between two parameters. Here, we are going to be dealing with dependent sample. I discussed a little bit about dependent sample with you before. If suppose you want to measure left hand with right hand, which one is stronger? So you will measure the strength of the left, strength of the right. And you put it in pairs. Otherwise, you will mislead people. Are we getting what I'm saying here? So when you put it in pairs, the next thing you will do is to take the difference. We generally, instead of saying left and right, we generally call it before and after. When you do the before and after, you subtract before minus after. Where do we get that here? And it will give you a new distribution. And you can use that distribution to test the difference. So the test for difference also have 3 types: left, right. So if I say, let's say D equals to B minus A, then mu D will be mu B minus mu A. So when I say mu D, is equal to 0, it means they are the same. Mu A equals to mu B. Mu B equals to mu A. If I say mu D is less than 0, it means mu B is less than mu A. These are the same thing. Do we get what I'm saying here? If I say mu D is greater than 0, it means mu B minus mu A is greater than 0, meaning mu B is greater than mu A. How do you know that the data you are going to get are paired? You will see that they are given to you 2 by 2. And you do first minus second to find the difference. We are going to use Excel to do this. So we use a T distribution. As we are going to look at this example, you are going to understand what we do in a test for difference. Here we are going to use Excel. What about it? You can use calculator too, but calculator will take longer time. But if you want, you can use calculator. But I want to focus on Excel here. A team of heart surgeons at St. Anne's Hospital knows that many patients who undergo corrective heart surgery have a dangerous buildup of anxiety before their scheduled operations. The staff psychiatrist at that hospital has started a new counseling program intended to reduce the anxiety. A test of anxiety is given to patients who know they must undergo heart surgery. Then each patient participates in a series of counseling with the staff psychiatrist. So we want to know if counseling will reduce anxiety. So before the psychiatric counseling, anxiety is higher, right? After, we expect it to be lower. And we will compare the two. That is our objective here. So the claim here is that counseling reduces anxiety. So we have this data. Do you want us to use calculator or Excel? Let me know. Somebody. Excel. Good. Let's go to Excel. You all on Excel. Enter the first data on A and the second on B. I cannot use Excel. I don't have data analysis. I have to put my computer off and on. I always forget to do that. But do you have data analysis? Okay, if you don't have, we can put it. So put column A, anxiety before, column B, anxiety after. Using Excel, put column B, column A, first column, anxiety before and after. No, only B and A. Difference, I could tell you to just do it. If you have this difference, if you want to do the test, you just put it on L1 on your calculator and you will do the test. The reason why I tell you that the calculator cannot do it because you have to put on L1, L2, do the difference, and before you proceed. But with Excel, you put it on A, B, and then you just go to data analysis. If you are done with A, B, column A and B, go to data analysis. Are you on data analysis? Then choose, go right down, you will see t-test for paired data. T-test for paired two sample for means. Do you see that? Okay, choose that. Then variable 1, you highlight what is on column A. We are comparing two averages. Average before, average after. Yes. When you do what? You go to t-test for paired sample mean or something like that. So enter variable 1, A, variable 2, B. If you have a question, let me know. You may choose output range, just like we did already before, just to indicate where you want your result if you want it on the same page as your data. Have you taken all the data? If you're on Zoom, you can use Excel. And if you have a question, let me know. We want to use alpha across 2.01. Do you have the results? Can somebody tell us what the test value is? No, you don't need to put that there. I don't think there is. Yeah, there is, but it doesn't really. It's 0.05 here, put 0.01, but it doesn't really affect the result. Because at the end, you will be the one to make the decision. Do you see T value? 4.36. Do you have the P value? For 1 tail and 2 tail. You can increase it if you like, for T less than, or T greater. Yeah, so that you can see what is written there. Do you have the P value? Can you see P value? Less than T. Okay. It's 1 tail. 1 tail is less than or greater. So, H0 is mu B equals to mu A, or mu D equal to 0. H1 is mu B is greater than mu A, right? Anxiety before is bigger than anxiety after. So, mu D is greater than 0, and this is the claim. Now, test value is X bar D. If you're doing it manually, you do that difference and take the average of that difference. When you take the difference, it gives you a new data. You take the mean and the standard deviation of that data. That's D over square root of N. I will never ask you this one. I will just ask you the test value. And we know what it is. So, the test value is 4.363. And the P value is what? 0.0012. So the other P value will be 0.0024. Have you noticed that? So it's for 2 tail. Okay? So if you are confused, just make sure that 2 tail it will be double, 1 tail it will be half. And you will see less than for 1 tail. And then I think they put there 2 tail or 1 tail. So this is 1 tail. So alpha equals to what? Do you remember? 0.01, right? Alpha was 0.01. Is P less than or greater than 0.01? P is less than alpha. So what is our decision? Reject. It's 0. So the conclusion will be at alpha equals to 0.01, there is enough evidence to support the claim that counseling will reduce anxiety. Do we get this? The conclusion will be there is enough evidence to support the claim that counseling, so hospitals should spend money to hire a psychiatrist that will help reduce counseling for those who are going in for surgery. At what percent level of significance we conclude that the counseling session reduced the average anxiety level of patients about to undergo corrective heart surgery? In your book, they don't pay that much attention in what I am trying to tell you, for which I spend so much time. You just answer the question. It's much simpler. But I want you to understand, because you might hear people speaking about it some days, and you will see some people say reject, some people say support. It depends on what was at stake at the beginning of the test. Okay. Now, we want to do the test for independent sample. This is exactly what you did for proportion, and we are just going to go to examples. It's exactly the same. We are dealing with two samples now. I will quickly write something so that we don't feel like we didn't write anything. But all of this is essentially the same type of thing. So we are going to say H0, mu1 equals to mu2 all the time. H1 will change according to the type of test. Mu1 less than mu2. Mu1 greater than mu2. Mu1. This is how we state hypothesis. Everywhere here, H0, mu1 mu1. This is how we state hypothesis for the difference. The test value will depend on whether there is sigma or not. If sigma 1 and sigma 2 are known, Z will be x1 bar minus x2 bar divided by square root of sigma 1 square over n1 plus sigma 2 square over n2. If sigma 1 or sigma 2 are unknown, we use T with degree of freedom equal to the minimum of n1 minus 1, n2 minus 1. You have this on chapter 7 already, and you have it on the PowerPoint. That's why I'm writing it first. This will be x1 bar minus x2 bar over square root of s1 square over n1 plus s2 square over n2. We are not doing the pool here. I'll just tell you, you use pool if for some information, the standard deviation of the population are the same. But we are just going to be using no pool whenever it comes up. Examples. A consumer group is testing CAM stoves to test the heating capacity of a stove. It measures the time required to bring 2 quarts of water from 50
degree to boiling at sea level. Two competing models are under consideration. 10 stoves of the first model and 12 stoves of the second model are tested. The following results are obtained. Let's use calculator for this. We'll be using Excel most of the time when we have data, calculator when we don't just have statistics. Go to calculator. Start, test, two sample, Z test, something like that. Can somebody see something, test, two sample, Z? What is it exactly? Have you all seen that? Two sample Z test. Use statistics. Okay. Use statistic and you have sigma 1, sigma 2. So don't complete the test because we don't know yet what the claim is. I just want us, before we go to the next slide. Have you entered the statistics? Assume the time required to bring water to a boil is normally distributed for each stove. Is there any difference either way between the performance of these two models? Use 5% level of significance. Here is there any difference between the two models? The claim will be there is a difference. So these are the hypotheses. Mu1 equals to mu2. Mu1 is different from mu2. So you have completed with different. Can you tell me what the test value is? What is the test value? 1.2. What is P? 0.001. 0.0. Okay, can you say it again? 0.201. Anybody else has 0.201? Okay, it's two-tailed. So now, alpha was 0.05. Is P greater than or less than alpha? Is P greater than or less than alpha? Greater than alpha, what should be our decision? Do not reject H0. Our decision is either to reject or not to reject H0 all the time. This is at the conclusion. And even that conclusion, you might not care too much about that so much detail I gave you. Answer the question. Just answer the question for now, for this our course. But I told you more about how it is for people that knows what they're talking about. So now, what should be our answer? Is there a difference or not? Do not reject H0. Is there a difference or not? H0 states no difference. If we do not reject H0, is there a difference? Can we say there is a difference between the stove? We do not reject H0, right? So there is no difference. So our conclusion will be at alpha equal to 0.01, there is not enough evidence to conclude that there is a difference between the two stoves. No need to change stove. Do we get that? So we use the Z distribution
when sigma is known, and the t distribution when sigma are unknown. So it is essentially going to be the same thing. I will advise you to do the homework, but I want us to see what to do when it is about proportion, then we can go. The last part is proportion. So if you are looking at the PowerPoint, there will always be an estimate for the p-value when we are dealing with the t distribution. Because the table, the t distribution table cannot give us the exact value. Ignore that because your calculator will give you the actual value of the p. If you are using the table, it doesn't give you. Just t distribution does not help you to find the p-value. Z distribution can help you to find the p-value, but T, it can only give you a range. Probably on Tuesday, if you have questions from your homework, I can explain how to do that estimate, but because we have calculator, it's not very important. And you can use, just an example for the P, so that you are able to do the homework. So when we are doing proportion, we will be comparing two populations. That will mean we will take two samples from each of the population, and they are independent. So what we are going to do here, which is called the pool proportion, is to put the two samples together. For example, we want to test if students at St. Francis University perform better than students from maybe Penn State Altoona. So we take the proportion, the student, a sample from St. Francis, a sample from Penn State. And to find the pool, we count the total of the sample. That is N1 plus N2. And R1 plus R2 is the success for both. This is just for the purpose of estimating a common proportion that will be used for the formula. You are not going to be doing it because you are using calculator. I'm explaining if you are doing it manually. So let's do this last example quickly. The Mache County clerk wishes to improve voter registration. One method under consideration is to send reminders in the mail to all citizens in the county who are eligible to register. My mail is full every day of those. As part of a pilot study to determine if this method will actually improve voter registration, a random sample of 1,250 potential voters was taken. Then this sample was randomly divided into two groups. Group 1, 625 were sent a reminder and 295 registered. Group 2, 625 and 350 registered. So in group 1, no reminder was sent, 295. Group 2, reminder was sent, 350. Let's get to our calculator. We go to start test, two proportion Z test. And then we get to two proportion Z test. We have N1, 625, X1, 295. N2, 625, X2, 350. The first group is the group that did not receive. So we want to say P1 is equal to P2. And want to say here that P1 is less than P2 because we want to say that remaining people will improve registration. So P1 is less than P2. Any questions from your calculator? So have you find the Z value? Alpha equals to 5%. What is the Z value? Pardon? Negative 3.11. You get that from your calculator. What is the P value? 9.26. Anybody else get 9.26? This is wrong. Like that. You have to read your calculator properly. Do you see E minus somewhere there? Yeah. Can I see what you see E? So this is, do you see E minus 4 here?
That's what you meant.
Yeah. 10 raised to power minus 4.
Yeah.
Okay. I knew that's what was happening. So times 10 raised to power minus 4. Do we all understand this? Probability is never bigger than 1, right? P value is a probability. So if you want to write some number bigger than 1, think twice. Maybe you didn't see this. Is this P less than alpha? This means 0.000926 actually. You put 4 decimals, you move 4 decimals. That is the meaning of this. So is it less than alpha? So we reject H0. Rejecting H0 means support H1, which is the claim. There is a good reason to spend money sending a reminder to voters. Sorry for this, but we had to finish this chapter instead of having to come back to it on Tuesday. But we will come back with questions and do the homework so that we have more to talk about on homework, and everything will be, yes. Yeah. Okay, we are done.